when we design the database, the first thing is to draw the ER diagram. Now, once the ER diagram is completed, now this ER diagram is available with the university database. Now, this ER diagram, this is the basic design of database. This ER diagram, I need to convert into the schema diagram. Schema diagram is relational schema. I need to convert it. Why? Because we create the tables and all these things which comes under the relational model. So in that case, this ER diagram, we need to convert or reduce it into the relational schemas. And that part now we are going to see. So in this ER diagram, already we have seen these entity sets are there. These are the relation between the entities. Now, all we try to convert into the relational schema. The topic is reduction to relational schema. Now, one by one, we are going to see strong entity, how we can reduce into the relational schema, then relationship set, how we can reduce into the relational schema. And in this way, the entire ER diagram, we try to reduce into the relational schemas. So the first, reduction to relational schema. So entity sets and relationship sets, can be expressed uniformly as relational schemas, that represent the contents of the database. Now, a database which conforms to an ER diagram can be represented unique as a collection of schemas or collection of tables. A database is nothing but the collection of tables or collection of schemas. For each entity set and relationship set, there is a unique schema is assigned the name of the corresponding entity set or relationship set. Means the instructor entity set is there. I want to reduce it to the schema, relational schema. The name remains as it is. The instructor entity set, suppose I want to reduce it to the relational schema, the name is as it is. Suppose the relationship set advisor, I want to reduce it into the relational schema, the name advisor remains as it is. So each schema has a number of columns which are correspond to the attributes. Each one has a unique name. So instructor schema, we reduce the instructor entity set into the instructor schema. So whatever the attributes of instructor entity set becomes the columns of that table. Now see it in detail, then it will be clear to you. Okay, so representing a strong entity set with simple attributes. We consider a strong entity set with simple attributes. No composite attribute, no multivalued attribute, no derived attribute. So how to represent a strong entity set with simple attributes as a schema? So let E be a strong entity set with only simple descriptive attributes A1, A2 to AN. An entity set E with attributes A1, A2 to AN. We represent this entity by a schema called E, means the name as it is, it remains as it is, with distinct attributes and attributes. Each tuple in the relation on this schema correspond to one entity of the entity set. Now, for example, strong entity set, the first we consider instructor. The strong entity set, first we consider instructor with IID, name and salary. IID, name and salary. So this is entity set. Now I want to represent it as a relational schema. So schema, when I represent it as an instruction schema, instead of instructor entity set, what we call it as a instructor schema, then what is the name of that schema? It is same as instructor. It is same as instructor, and the attributes of the entity set becomes the columns of that schema or the columns of that table: ID, name, and salary. So in the table form, how we write it? In this way, we write it in table form. That is ID, name, and salary. For example, I write here F101 name XYZ with salary 80,000. Then F102 PQR with salary 90,000 in this way. So this entity set we represent as a schema. Okay, name remains as it is. Its attributes become its columns, and in the table form we represent like this. So the meaning of this third one is that each tuple in a relation on this schema is represent one entity. So this is the first tuple which represent entity 1. It is entity 2 up to whatever n number of entities in the table. So in this way, entity set we can represent as a schema or relational schema. Another example, if we consider department. The second way to write a schema as name of the schema and in bracket name of the attributes or name of the columns in that schema. So department entity set has 3 attributes: department name, and these attributes become the column of that schema. So department schema, I write here, sorry, department schema with department name, then building where it is located, and budget. So when I represent it in the form of table, it becomes like this. I draw here department table with 3 attributes: department name, then building, and budget. Department name, building, and budget. So first, whatever department name CSE, it is in main building with some budget 10 lakh. Then make, it is in mechanical building separately, if we say with budget 20 lakh, in this way. So this is the first entity, this is the second entity from this schema. Similarly, I say core schema. So course entity set we convert into the core schema. In the course entity set, there are 3 attributes which becomes the columns of this schema: course ID, course title, and credits. So in this way, every strong entity with simple attributes, we can represent it as a relational schema. We can represent it as a relational schema and represent it as a table. Classroom, department, course, instructor, student, these are some example of strong entity set with it's a schema. So table is given here, one example. And every tuple in this is considered as a one entity. So how many entities here? In this there are 7 entities. Each one is distinguishable from other entity. Now we move towards to the composite and multivalued attribute. If there are composite attribute and multivalued attributes in the entity set, then how to represent that composite attribute and multivalued attribute? So when we consider the ER diagram, how we represent the composite attribute and multivalued attribute? So composite attribute name, it is divided into, or intent is used to indicate that these are the 3 components of this composite attribute. Similarly, address 4 components, again street is divided into 3. So in this way, composite attributes we normally refer or show in the we normally show in the ER diagram. Now, how to represent these composite attributes? If there is a composite attribute in the entity set, then how to represent it with the schema or with the form of table? When we go to the table, creation of the table, reduction of ER diagram to relational schema. So, in that case, the composite attributes are flattened out by creating separate attribute for each component attribute. By creating separate attribute for each component attribute. So here in this case the name has three component attributes. So how it is written? Name dot first name. Instead of writing name only, name dot first name, then name dot middle name, name dot last name. But if there is no ambiguity, if these component attributes names are unique, then not necessary to use this prefix. If these component attributes, these are unique names, though not necessary to use the prefix. Only you can use first name, middle name, last name. Similarly for address. So we can represent is address dot street. Dot street number, address dot street name, address dot street dot apartment number. But if there is no ambiguity, all the component attributes has unique name, not necessary to use the prefix. So in this case, don't consider this one and this one, we will see afterwards. In this case, without considering the multivalued and derived attribute, how we represent the instructor schema? We represent the instructor schema. What are the attributes of the instructor relation? What are the attributes of the instructor table that we are going to create? ID. So, first name, middle name, last name. These are written separately as these are composite attributes. Then last name. After that address. So instead of using the prefix, I directly write here street number. Okay, street name. Then apartment number. City, state, zip, and date of birth. Okay. About the multivalued attribute, we'll see after that. So when we create or convert this entity instructor into the relational schema, then in that case, the composite attribute, we write its component attributes separately. We write its component attributes separately. So that is the way we represent the composite attributes. So the same example is given here. Prefix omitted if there is no ambiguity. Ignoring multivalued attribute, this instructor schema is represented in this form with all the components of the composite attributes. Now the multivalued attribute. How we can represent a multivalued attribute? So a multivalued attribute M of an entity set E is represented by a separate schema EM. So here for a multivalued attribute M, if it is present an entity set E, we represent it as a separate schema, means separate table. We represent it as a separate table with the name EM. Schema EM has attributes correspond to the primary key of E. So what are the attributes of this separate table or separate schema? The attributes of this separate schema is the primary key of E and the multivalued attribute M. These are the attributes of the corresponding new schema. Now see it with example. In our case, phone number, multivalued attribute, phone number. So a person has, it is possible that a person has multiple phone numbers. Instructor has multiple phone numbers. So instructor ID is there as a primary key and multiple phone numbers. So we create a new table, instructor phone, with two attributes. The first attribute is the primary key of instructor, that is ID of the instructor, and second one is phone number. Now the instructor F101 has three phone numbers. Okay, he has three phone numbers. Then there are three entries for F101 with 917698 in this way. Means we create a separate schema, separate table if there is a multivalued attribute in that entity set, considering the primary key of that entity set and that multivalued attribute. Why we do it? To avoid the duplication. To avoid the duplication. Suppose this phone number is a multivalued attribute and it is we add into the original table. What happens here in the original table? Suppose ID is there, name is there, salary is there, and phone number is there. So if F101, this faculty or this instructor has three phone numbers, then I need to add its all details 3 times. I need to add its all details 3 times in this way for every phone number. And to avoid this duplication, we do this thing, that we create a separate table with the help of this multivalued attribute. So that is shown here with example. I already shown you the example. Okay, the same example is given here. If the instructor has multiple phone numbers. In the same way, dependent name, if that particular employee has 4 to 5 dependent names, then we create separate table, separate schema, the ID of that employee, employee ID, and whatever the dependent. So it avoids so much redundancy. It avoids so much redundancy. And that's why remember that whenever there is a multivalued attribute in the entity set, we need to create a separate schema for that. Now, representing weak entity set with simple attributes. If there is a weak entity set, represent with simple attribute. Then, a strong entity set, reduce schema. We have seen, suppose the student with ID, name, total credit, etc. A weak entity set becomes, what are the values of the tables, what are the contents of that schema, what are the attributes of the schema if it is a weak entity set. Now course, how we represent course? It is a strong entity. So when we represent it as a schema, core schema, then it includes 3 columns or 3 attributes: ID, title, and credits. So that is about the strong entity set. Now I want to represent it. I want to represent this weak entity set. So when I want to represent this weak entity set, it has 3 discriminators or whatever the number of attributes, but it does not have a primary key. So when we want to represent a weak entity set, the primary key of strong entity set becomes the, or need to add here. Need to add here in this. So how I represent section entity set as a section schema as first the primary key of the strong entity set on which it depends, along with section ID, semester and year. Now, what is the primary key of course? It is this one. What is the primary key of section? Course ID, section ID, semester, year. Its own discriminator plus the primary key of strong entity set. So, we represent a weak entity set. When we represent a weak entity set as a schema, relational schema, we need to add the primary key of strong entity set in its columns or in its attributes. So, this is the way we represent a strong entity, weak entity set and strong entity set. Okay. So, course ID is added here as a primary key of strong entity set. Now, represent the relationship set. This part, some of this already we have learned previously. Again, I am going to repeat it. So, represent the relationship set. If it is many to many relationship set represented by a schema, so it is a relation. Example, advisor is a relation between the instructor and student. So how we represent the advisor relation? This relation contains the primary key of instructor and primary key of student, that is IID and SID. So how we represent the advisor relation? Advisor schema, the primary key of instructor and the primary key of student. And then what is the primary key of this advisor schema? It depends upon whether it is one-to-one, one-to-many, many-to-one or many-to-many. If it is one-to-one, we can use either this one or this one. If it is one-to-many, if it is one-to-many from, if it is one-to-many from student to instructor to student, one instructor, many student, then what is the primary key of this advisor schema? The primary key of the advisor schema is IID. Sorry, not IID, SID, many side. Opposite, if it is from here to here, one to many from student to instructor, one student, multiple instructor, then what is the primary key of advisor schema? The primary key of advisor schema is at many side. And if it is many to many as shown here already, if it is many to many from one student, multiple instructor or one instructor, multiple student, then union of these two becomes the primary key of the advisor schema. So in this way, any relationship set we can represent as a schema, relational schema, or in the form of table. So advisor table, how I can draw here? Advisor as IID and SID. So F101 associated with that, for example, student 101010 something. F101 has multiple student 202101 something. F102 with 11111. In this way, we represent the advisor relational schema. Okay, so relationship set also we represent as a relational schema. That is shown here. Another example, teaches relational set, relationship set. It is a relationship set between the instructor and the section. The instructor teaches this section. So that is shown here. It is a relation between the instructor and section. So instructor has IID, name, salary. Section has, already I have shown that course ID is added here. Why? Because it is the primary key of strong entity on which it depends and its own discriminator. So instructor and section, these two relation schemas, for that the relation is, suppose I write instructor section. This kind of relation. Name of this relation, instructor section schema. So it is the primary key of instructor and the primary key of section combination. Primary key of instructor and primary key of section. Together all becomes the columns or attributes of this instruction section schema. All become the columns of this table instructor schema. Instructor section schema. Similarly, all other relationship set we can represent here. Means here in the same way text. How we can represent the text relation? This text relation. So it is a relation between the student and the section. So when I write the text schema, what are the attributes of this schema? It is the primary key of student. I write here SID and the primary key of section. So what is the primary key of section? This is course ID, section ID, semester and year. Okay. So when I represent text schema, in this schema the attributes are the primary key of student and the primary key of section. Primary key of student is SID and the section is course ID, section ID, semester and year. Is it clear, complete here? No. Why? Because this text has its own descriptive attributes. The text has its own descriptive attribute, that is grade. That also we need to add here. That also we need to add here. If the relationship set has its own descriptive attribute, we need to add that when we show it as a schema. Now what are the primary key? It is many to many. You can observe here it is many to many. So the union of all these becomes the primary key of the text relation or text schema. But here we added a grade. Why? Because grade is the descriptive attribute of that schema. Okay, and it is shown here. All the relationship sets are represented here with primary keys of the entity set that participate in that relationship set.
Redundancy of schemas. In some cases, it is possible that when we reduce ER schema to the relational schema, it may be possible that two or more relations have the same attributes. So we create the duplication of the schema and we need to avoid this duplication, as this is one of the major property of the database system. Avoid duplication, avoid redundancy. So I am using the word avoid always because it is not possible that completely reduce or completely ignore the redundancy. In some cases we need to use the redundancy, but we try to avoid the redundancy, and that's why when we convert an AR schema to the relational schema, if there are multiple schemas which has the same attribute, we need to remove that schemas from that schema diagram or the entire database design. Now see with example redundancy of schema. One example we are going to see here. So a relationship set linking a weak entity set to the corresponding strong entity set is treated specially. A relationship set which is linking a weak entity set to the corresponding strong entity set is treated specially. What we call that relationship set? We call that relationship set as a identifying relationship set. It possesses three properties. The first one is that it is always many to one from weak entity set to the strong entity set. Okay. It is weak entity set to strong entity set. It is always many to one. Then the participation of weak entity set is always total in that relationship set, identifying relationship set. and the identifying relationship set does not have its descriptive attribute. So these three properties always possessed by this identifying relationship set. Now see the redundancy of schema, how we can reduce the schema. For example, this is our simple schema diagram, ER diagram, in which there is a strong entity set course, there is a weak entity set, there is a weak entity set section which depends upon the strong entity set. So course is the strong, weak is section is the weak entity set, and the identifying relation is section course. We call it as a identifying relationship set. Okay. Now this ER diagram, consider this one only. We are going to convert it to the schema diagram. So we start with always the first strong entity set. So strong, when we convert this ER diagram to the relational schema, the first one is the course. So course is the strong entity set with the three attributes. So the schema has the same name. Relational schema has the same name. Course schema, and the attributes of this course schema are course ID, title, and credits. Okay, so these are the columns of this table when we convert this ER diagram to the relational schema. Now this section is the set which depends upon the course. So when we convert it into the relational schema, section schema has as all its attributes along with the primary key of the strong entity set. So first I write here primary key of strong entity set, that is course ID, its own attributes, discriminators, all, section ID, semester, and year. Now what is the primary key of course schema? It is as it is the primary key of the original entity set, as it is the primary key of the original entity set. Now section schema has, what is the primary key of section schema? It is the primary key of the strong entity set along with the primary key of or discriminator of the weak entity sets. So here when we move towards the next course schema and section schema, now we have to convert the identifying relationship set into the schema. So when we convert this identifying relations into the schema, then in that case, what are the attributes of this section course? What are the attributes of this section course schema? What we consider here as the columns of the section course schema. Okay. So see, when we consider or when we convert the relationship set into the schema, primary key of both the entity sets we need to add here. Whatever the entities participate in that relationship set, all primary keys we are considered here. So here in this the section course, the attributes of this section course is the primary key of course ID. So the primary key of course is course ID, and what is the primary key of section? It is course ID, section ID, semester, and year. Course ID already I have written, so not necessary to write it again. So I write here section ID, semester, and year. Section ID, semester, and year. So these are the attributes of the section course schema. Now what is the primary key of section course schema? As it is a many to one, the many side at whatever the entity set, its primary key becomes the primary key of the relationship set. Many side is the section. So section primary key is all this. Okay. Now when we observe these two this one and this one. What we observe here? Both have the same attributes. Primary key is also same. Both have the same attribute and the primary key is also same. And that's why the section course schema, it becomes redundant. What we call? We call it as a redundant. Why? Because it is duplication of the section schema. So when we store it in the database, we try to avoid the redundancy and this section code schema becomes redundant, and that's why not necessary to store it into the database or not necessary to create such kind of tables. So it is a common that in general the schema for relationship set linking a weak entity set to the corresponding strong entity set is always redundant and does not need to be present in a relational database design based upon the ER diagram. So when we convert the ER diagram into the relational schema, whenever there is an identifying relationship set, it is always redundant and not necessary to be present in the relational database design. When we convert this into the schema diagram, this not necessary to create the schema. That is about the redundancy of the schema. That is redundancy of schema. Now the next one, that is combination of schema. So consider a many to one relationship set A, B from entity set A to entity set B. Okay, I'm going to draw here. Consider a relationship set AB from entity set A to entity set B. What is given here? Suppose further that the participation of entity set A, the participation of entity set A in the relationship set is total. The participation of entity set A into the relationship set is total, means every entity in A associated or participate in the relationship set AB. Then this relation A to B, it is many to one. Okay, consider a many to one relationship set from A to B. See, if there are two conditions, first one is that it is a many to one relation from A to B and the participation of A is total. Then we can combine the schemas of A and AB. We can combine the schemas A and AB to form a single schema consisting of the union of the attributes of both schemas. We can combine these A and AB. We can combine these A and AB to form a single schema consisting of the union of the attributes of both the schema. The primary key of combined schema is the primary key of the entity set. Means whatever the entity set of primary key of A is the primary key of that combined schema, and it is known or the name given as the whatever the name of the entity set. Means we are going to combine the schemas. Okay. Now see it with example in our university database, then it will be clear. So here this one instructor to department, it is, you can observe, it is many to one. Okay, it is many to one instructor department relation, and the participation of instructor is total. Means what? Every instructor is associated with at least one department through the instructor department relation. So what are the attributes of the instructor? Sorry, when we convert this simple one, consider these three only, this one and this one. Forgot about this. So when we convert it into the relational schema, first I write here department schema with attributes department name, building, budget. Okay. Now when we see the instructor, what are the attributes of the instructor schema? Instructor schema, the attributes are IID, I write here IID, name, name and salary. Okay. Now, what are the attributes of instructor department? It is a relationship set. So when we convert this into the schema, the primary key of both the entity set that participate in that relation becomes the primary key of the or becomes the attributes of this. So it is department name, comma, IID. And what is the primary key of instructor department schema? It is the primary key of the entity set which are at many sites. So many type is instructor ID. So instructor ID is the primary key of the instructor department. But according to the combination of schema, if it is a many to one, this relation is many to one and the participation of instructor is total, then we can combine these two schemas. We can combine these two schemas and generate a single schema with the name instructor. So instructor schema becomes like this. Instructor schema with attributes combination of these two, IID as the primary key of the instructor becomes the primary key of this schema, IID, name. Now department name I am going to add here and department name and salary. And that's why when we observe the schema diagram for this, department name is there in the instructor relation. Actually, in the instructor, there are only three attributes, ID, name and salary. But department name is also added there. Why it is added? Because this using this combination of schema method, it is a many to one from instructor to department and the participation of the instructor is total. So in the same way, when we consider the student and the department, again it is many to one from student to department and the participation of the student is total. So when we generate the or convert this simple ER diagram, these three we consider only, the department schema is like this: department name, building and budget. Now when we generate the schema for student, it is student with SID, name and total credits. SID, underline the SID. And then student ID, student department. This relation we convert into the schema. It is the primary key of the department and the primary key of the student, SID and department name, where SID is the primary key. Now according to the combination of schema, we need to union of these two together generate a single schema with the name of student. So student schema is now the combination of these two. SID is the primary key, then name of the student, then department name of the student and total credits. Now what we observe that in both the student and the instructor, department name is there. What is this department name now here? Department name is added here with the help of combination of schemas, correct? With the help of combination of schema method, we add department name here. So it is a foreign key. Department name is a foreign key. Why? Because it is the primary key of the department schema which is present in the instructor and the student schema. It refers to that department. The instructors are from this department and the students are also from this department. So in this way, we can apply the reduction of schema and combination of schema. And when we apply all these things together, this ER diagram, whatever we have seen, it is converted into the schema diagram. It is converted into the schema diagram. So department name. So first start with the department name. So department name, it not depends upon anything. So first we convert it into the schema department, department name, building and budget with department name as a primary key. Then we go for this instructor and department. Again, already I told you previously, it is a many to one and the participation of instructor is total. So we need to combine these together. So instructor schema is like this. It is here. ID, name, department name and salary. Means in ER diagram, department name is not there in the instructor, but in schema diagram it is there. Why? Because using the combination of schema. Now department name is there, so it is a foreign key. So you can observe here. So you can observe here what it indicating this line dependency. This is a foreign key which is refers to the department name. Similarly, this student and these two are combined together and we get the student schema. You can observe in the student there is no department name, but in schema it is there department name which is a foreign key reference to the department. These arrows are used there for this purpose to indicating the dependency. Next course, again you can observe course same. It is a many to one. Participation of course is total into the department. So these two are combined together. We need to make the union of these two schemas, and then course we need to add department name also as a foreign key, which is shown here with the reference. Next, for this teaches, okay, teaches, it is a relation between the instructor and section. So teaches is shown here. It is the instructor ID, then it is a section. So section include the course ID also as it's a primary key. So the teacher schema has 5 attributes: ID, instructor ID, course ID, section ID, semester and year. In the same way text. So it is a relation between the section and the student. So need the primary key of both. Student primary key is ID, SID. Section primary key is course ID, section ID, semester, year, and grade is its descriptive attribute. Grade is its descriptive attribute. So in the way section is shown here. After that, classroom, prerequisite, advisor is the relation between the instructor and student. It is many to one, but participation is not total. And that's why it is not redundant. It is not redundant. We have to show it. Why? Because it possesses only one property. It is many to one, but participation is not total. And that's why it is the primary key or include SID and IID as the attributes of the advisor. And everywhere the arrows are shown here to indicate the dependency. Now you can observe here these relationship sets are not represented here. This one also not represented here. This one is also not represented here. And this one is also not represented here. So these three are not represented with the method of combination of schema, and these three are not represented. Why? Because these are identifying relationship set which becomes redundant. And that's why these 6 relationship sets are not represent in this entire schema diagram. And when we represent the relationship set, you can observe here SID and IID. SID, it is the primary key, along with it is a foreign key referencing to the student. IID is also a, you can observe, foreign key here in this. Why? Because it is reference to this instructor. Means it is also dependent. In this way, any ER diagram, we can convert it into the schema diagram. And that part is the reduction of ER schema to the relational schema.